Welding EV battery shells. Seams must be sealed, reliable, and uniform. Can hand welding really hold that? 3 pits of battery shell welding. The shell is thin. A little excess heat warps it and leaks. Seams are long and cycle tight, so manual speed and consistency trade off. And fast EV model changes mean retraining welders every time the seam path changes. This cell pairs a collaborative robot with a laser welder, tracking the battery shell seam with high precision. Concentrated, controllable laser heat and stable speed produce uniform, attractive, consistent welds. Laser welding's small heat-affected zone resists warping on thin shells for a more reliable seal. High-path accuracy keeps seams straight and even, with appearance consistency far beyond manual work. Drag to Teach Plus, a welding software package, sets laser power, speed, and start-stop in a few steps. With live process monitoring, no dedicated robot engineer needed to program. The payoff is direct. Versus manual welding, quality and consistency jump while labor cost drops. On an EV customer's battery shell application, payback ran as little as 6 months. Model changes are no problem. A new seam path is just a program change, small batches and many variants on demand, flexibly absorbing the fast EV cadence. Thin shells, long seams, fast cadence. A collaborative robot with laser welding turns battery shell welding into a consistent, low distortion, fast payback standard process. This is EVST. We make line automation real.